Welcome to lecture series on applied physics. Today we are going to discuss on the historical development of optical fiber communication. I am Dr. K. Subramanian, Assistant Professor, Department of Physics, SRM Institute of Science and Technology, Ramapuram Campus, Chennai, Tamil Nadu. In today's lecture, we are going to cover the topics: what is communication, evolution in the communication methods, what is optical fiber, and finally copper wire versus optical fiber. First, let us discuss on what is communication. This communication process involves in exchanging the words, signs or any other information with others. So, there are so many communication tools employed from ancient era till date. Before we discuss on optical fiber communication, let us discuss on the evolution in the communication methods from ancient times. It is quite interesting to view some communication techniques here. In ancient time, the smoke signal, cave paintings, carrier pigeon, postal system, newspapers, radios, telegraphs, internet, cell phone, now optical fiber communication. First, let us analyze what is a smoke signal. The smoke signal is one of the oldest forms of the long distance communication. It is a form of visual communication used over a long distance. In general, smoke signals are used to transmit news, signal danger, or to gather people to common area. As we know, when the fire gets off, the smoke takes a longer distance, that is a height, longer altitude. So, anybody can see from any area the smokes, so that by the same time the smokes give the all kind of the communications. Next one is history of cave paintings. The cave paintings were created between 43,000 and 65,000 years ago, 20,000 years before modern humans arrived in Europe. In 2018, research announced the discovery of the oldest known cave paintings made by Neanderthals at least 64,000 years ago. Next communication system is a carrier pigeon. Historically, pigeons carried messages only one way to their home. They had to be transported manually before another flight. However, by placing the food at one location, their home, at another location, pigeons have been trained to fly back and forth up to twice a day, reliably covering round trip flights up to 160 km. So, the pigeons can carry the message from one point to another point even in the more than the month. The pigeon can return back. Next communication system is a postal system. The Warren Hastings had taken initiative under East India Company to start the postal service in the country in the year of 1766. Nowadays, we are using the postal systems. The postal systems nowadays taking the letters from one place to another place. Also, we can send the parcels from one place to another place. It is not only used for communication, but also it is used as a logistics service. And one of the important communication tool is the telegraph. In year of 1843, the Morse built a telegraph system from Washington DC to Baltimore with the financial support of the Congress. On May 24, 1844, the first message, "What hath God wrought," was sent by the telegraph. This telegraph is made by the Morse code, dots and dashes. So, with the help of the analyzing the dots and the dashes, one can read the message by using the telegraphs. Radio communication. In the mid 1890s, building on techniques physicists were using to study electromagnetic waves, the Marconi developed the first apparatus for long distance radio communication, sending a wireless Morse code message to a source over a kilometer away in the year of 1895. The radio communication is playing the vital role now today also. The radio frequencies are not only used for audio communication, but also it is used in the video communication. As we know very well, the video signal consists of both audio as well as the video signal, but the audio signal has to be modulated by frequency modulation. Video signal has to be modulated by the amplitude modulation. After modulation, the modulation is a technique of superimposing a signal into a carrier wave. Signal is whatever coming from the mic and video. So, these signals has to be superimposed in a high frequency carrier wave. This technique is called as a modulation. As I rightly said, the video signal has to be amplitude modulated wave and audio signal has to be a frequency modulated wave. Both amplitude modulated wave and frequency modulated wave both will superimposed and they sent for the long distance. In radio communication, there are so many techniques nowadays. So, the frequency modulation radio waves can be telecasted within the short range. The telegraph system was inadequate form of the communication because it required users to learn Morse code, because I said that Morse code is in the form of the dots and hyphens. So, the dots and dashes, one who is skilled only know the Morse code. So, not a common man can understand the Morse code. This problem is inadequate for the communication. This problem can be overcome, and this was not possible to send the more than one message at the same time. Bell discovered that it might be possible to create harmonic telegraph through which differently pitched sounds can be transmitted through the same wire. So, in the year of the 1876, the Alexander Graham Bell invented the phone. Over the decade, so the phone's shapes are changed and now we are using the mobile phones. Next communication tool is the internet. The internet was developed with the different timelines. Once the internet is already started in the year of the 1965. So, after that in the year of the 1994 only we have the Netscape navigator system. Instead of the app, the navigator system was developed in the year of the 1994. So, after that the remarkable development was achieved and now we are using the ultra fast internet connection through the up to 5G. Evolution of the mobile phones. The mobile phones are already launched in the year of the 1985. So, the Motorola was the first company launched the mobile phones, and later Nokia and different models of the mobile phones are developed. Earlier the mobile phones are developed only for the communication purpose. The first mobile phone was developed by the Motorola in the year of the 1973. The headset is weighing up to 2 kilograms. So, later the signal antenna size was reduced and nowadays the mobile phone antenna was much more reduced and the signal is absorbed by the handset itself. And nowadays the mobile phones are one which is in which we can use the computer applications also. So, first let us see what is optical fiber. The optical fiber is manufactured by the material glass silica. So, in which the light pulses instead of electrical pulses to transmit information from one place to another place via the glass medium guide. The glass medium is acting as a waveguide. Before stepping into the optical fiber communication, let us discuss on the historical development of the optical fiber communication. See, in optical fiber, the fiber optic cable can be laid in many places, from one place to another place and one continent to another continent via ocean. That is ocean laid optical fiber cable. So, fiber optic communication, the most electronic communication was carried by copper cables in early days. What is the problem with the copper cable? When the data are transmitted through the copper cable, due to the resistance, the power loss happens. Whether the twisted pairs are coaxial cable or copper waveguides, so these waveguides can able to send the data in the form of electrical signals. Communication was accomplished by sending electrical signals through the copper cables or waveguides. In recent years, a new medium has been introduced, that is called as optical fibers. In optical fiber communication, the light signal can transmitted from one place to another place in the place of the electrical signal. This branch of the science is called as a fiber optics. Why fiber optic communication? The invention of the telephone in 1876 brought a major change in as much as electrical signals were transmitted in analog form through a continuously varying electric current. This coaxial cables can be used in the place of the wire pairs. This increase the capacity, that is a data transmission capacity. The first coaxial cable system put into the service in the year of 1940 was 3 megahertz system capable of transmitting 300 voice channels or a single television channel. Let us see what is coaxial and microwave systems. The first microwave system operating at the carrier frequency of 4 gigahertz was put into the service in the year of 1948. Since then, both coaxial and microwave systems have evolved considerably and are able to operate at bit rates in the range of 100 megabit per second. The most advanced coaxial system was put into service in the year of 1975 and operated at a bit rate of 275 megabyte per second. This picture, it gives a clear explanation how the optical communication systems developed from year to year. So, in the early 1900s, the telegraph and the telephone can give the bit length, that is bit length is the product of the bit and the length, that is called as a bit length. So, in the year of the 1900, the telephone gives the bit length of the 1000, that is 10 power 3. So, in the year of 1950s, the microwaves are developed, it gives a bit rate of 10 power 6. So, later on, after invention of the laser, the light waves are opted to transmit data from one place to another place. It gives the bit rate in the range of 10 power 9 bits kilometer. So, finally, the optical amplifiers nowadays we are using, especially the erbium doped optical fibers or so called the optical amplifiers, they are having the bit rate in the highest power of the 10 power 12. The copper wire versus optical fiber. Why we are using the optical fiber in the place of the copper fiber? As I earlier told that the copper, it is made up of copper atoms and electrons. When it is transmitting from one point to another point, due to the resistance, the enormous power loss happens. Moreover, the copper is somewhat higher amount and optical fiber, the cost is very less. Compared to the copper wires, fiber optic cable have a much larger bandwidth, about 60 terabyte per second compared to the 10 gigabyte per second in the copper wire. Compared to the copper cables, fiber optic cables are very thinner and lighter in weight. The fiber can withstand more pull pressure than copper and less prone to damage and breakage. Moreover, the fiber is made up of the glass, so it is so flexible, it can be bent easily and compared to the copper cable. An optical fiber has no radio frequency interference, that is RFI, and electromagnetic interference issue. So, because it is not a conductor, it is transmitting only light from one point to another point, unlike copper cable. So, when the light is transmitted through the optical fiber, first whatever the data, it is called as a signal. The signal need to be converted in the form of the light by light emitting diode. This light emitting diode can produce the light pulse according to the data. The data is so called as a signal. This light is launched at a particular angle, that is called as a launching angle into the fiber. So, the light is carried by the fiber in the form of the total internal reflection principle. That principle I will explain in the forthcoming series. So, the light can be transmitted in the form of the total internal reflection inside the core medium. So, after reaching the destination, the light has to be converted in the electrical signal. For that purpose, we need spin diode or called a photodiode. This photodiode will be converting the light into electrical pulse. After that, since the light has transmitted from long distance, it will be somewhat the attenuation happens. The word attenuation stands for the power loss. So, that we need to amplify the signal. So, after amplification, we can modulate the signal and we can expose the signal. So, the optical fiber has no radio frequency interference. So, in early days, the laser light was used in the optical fibers as a light source. A severe drawback of such high speed coaxial systems is their small repeater spacing, that is 1 kilometer, which makes the system relatively expensive to operate. So, the invention of the laser and its demonstration in the year of the 1960 solved the first problem. It was suggested in 1966 that optical fibers might be the best choice, as they are capable of guiding the light in the manner similar to the guiding of the electron in the copper wires. So, one remarkable property of the laser is highly coherent. The laser, as we know very well, it is a high intense beam, it is having the monochromatic and its directionality, and moreover the very remarkably it is coherency, high coherency. Here in this chart, I have portrayed the historical perspective of light wave systems. So, the increase in the band, the bit length product over this time period. So, here 4 generations, during the 4 generation, each generation is having the remarkable wavelength operating point and the data, bitrate and repeater spacing. What is repeater? The repeater is a one which will amplify the signal at wherever the power loss. So, once the data is sent through the optical fiber, so the loss medium, that is the optical fiber medium, will absorb the light at the certain kilometer, the light will be totally absorbed. We are in the position to amplify the light. So, in the first generation, the light is given at the 0.8 micrometer wavelength. The wavelength operating point is 0.8 micrometer. The data bitrate is 45 megabyte per second. The repeaters are required at the end of the 10th kilometer. So, somewhat the second generation, the operating wavelength is increased from 0.8 micrometer to 1.3 micrometer, and the bit rate is quite increased from 45 to 1.7 gigabyte per second, and the repeater spacing is 50 kilometer. Compared to the first generation, for every 10th kilometer we need to replace the spacing, repeater spacing, but here in second generation, so the repeater must be placed only up to 50 kilometer. Every 50 kilometer we need to space the repeaters. In third generation, the wavelength operating point is quite increased 1.55 micrometer at the bit rate of the 10 gigabyte per second. The repeaters are required only at the 100 kilometer. The fourth generation, it requires the wavelength is the WDM, wavelength division multiplexing technique. In that wavelength division multiplication technique, we can involve both internet, TV channels and telephone line all in one single cable. So, this is a very remarkable technique, the fourth generation technique, in which the data transmission, it takes 10 terabyte per second. So, the repeater spacing greater than 1000 kilometer. So, this is the historical perspective of the light wave system. So, first generation to the fourth generation. So, the wavelength division multiplication technique, from which we can send any type of the data in a single fiber. The fiber diameter is very thin, it is 1/6 of the thickness of the human hair. In today's lecture, we have seen elaborately the history of communication, the fiber optic communication, optical fiber systems, historical perspective of light wave systems. In future next lecture, I will explain about the advantages of the optical fiber communication and types of the optical fibers and principle of the light transmission in the optical fibers, especially total internal reflection process, in which we are going to discuss on the structure of the optical fibers. Thank you.